In this video, I'm going to tell you about the universe at the time that the photons that make up the cosmic microwave background were released. So we're going to take a look at that universe, and then we're also going to discuss the cosmic microwave background, the predictions made of its existence, and the discovery thereof. Let's get right into it. Just about 380,000 years into the universe's existence, the plasma that's filling the universe of electrons, nuclei, and photons reaches the point that electrons can now affix themselves in a stable manner to these nuclei, and the photons are released. And we have a world that goes from a plasma of ionized nuclei to a gas of stable atomic nuclei and atoms of hydrogen, deuterium, helium-3, helium, and lithium. Before this period, during this period, and after this period, the universe continues to expand. At this period, it traverses the temperature of 3000 Kelvin, and as it expands, the density continues to thin out, at this point reaching a density of about 250 protons per cubic centimeter. But the crucial part of our story aren't the electrons that are making up the gas, but rather the photons that are no longer interacting with those electrons and are now free to roam the universe. Those photons make up the cosmic microwave background. They reflect this period of time in the early universe when the universe was very, very hot and filled with plenty of radiation all over. Now, while that happened 380,000 years into the universe's existence, it would take until 1964 for us to discover it. Already in the 1940s, predictions had been made that the early universe would have had this hot radiation that should be detectable now if the Big Bang Theory was true. However, because those theories in the 40s were tied to a specific theory of how all the elements came to exist in our world, and that theory turned out to be wrong, the other aspect, predicting that the early universe would be filled with radiation, was neglected and nobody pursued it until we reached the 1960s, when two people independently in Russia and America both think of this idea again, that the early universe would have this radiation permeating the whole universe and that should be detectable. Both of them thought about it independently of each other and independent of that first 1940s prediction. One of these people, Robert Dicke at Princeton University, then began to arrange an experiment so that he could test this. However, he didn't turn out to be so lucky. In 1964, the CMB was detected. Not by Dicke, though. Instead, by two individuals, Arno Penzias and Robert Wilson, 30 miles away from Dicke at Princeton University. Penzias and Wilson had no idea what they had detected. They were interested in running their own experiments, and all they cared about as good scientists was cleaning up the noise that their telescope was reading so that they could have no noise when striving to make the detections that they were going to be making themselves. But they had this rather long wavelength, low temperature radiation hitting the telescope from all directions at all times. While they, with mounting frustration, tried to get rid of the problem and find the source of this noise, they were unsuccessful, and eventually one of them stumbled upon somebody who was familiar with the work in Dicke's group, and he let them know, hey, I think you guys discovered the birth pangs of the cosmos. So the people who discovered the CMB and then got the Nobel Prize for their discovery of the CMB were not people who knew what it actually was. Instead, they were just scientists who were doing good science and trying to make sure their instruments didn't have any extraneous information coming in. Let's jump back to the early universe 380,000 years in. At this point, the universe was expanding, continuing to thin out, continuing to decrease in temperature, and with all the photons having a newfound freedom to stream across the universe freely. At this time, as these photons were freed, they were of the wavelength that would appear to us as a dull orange. But with time and expansion, they decreased in temperature to appear red, then crimson, and finally, about 5 million years in, most of the photons were in the infrared, and the universe would have gone dark to our eyes. And in this darkness, matter stirred. But that's for our next video on the cosmic dark ages. If you like this video, please like it, and if Big History is for you, be sure to subscribe.